Matter does not exist the way you think it does, and the experiment that proves this fits on a napkin. At the smallest scale, reality refuses to choose a position, not hidden, not waiting, undefined. And that difference breaks classical physics. This is not philosophy. This is a laboratory result. Imagine firing a single particle at a wall with two narrow openings. Common sense says it must go through one slit or the other. It cannot go through both. That would violate logic. Physics disagrees. In 1801, Thomas Young performed the original double-slit experiment with light. Two slits, one screen. If light were particles, you would see two bright stripes. Instead, he saw an interference pattern. Alternating bright and dark bands, light behaved like a wave, strange but manageable. Waves interfere. Water does it, sound does it. No crisis yet. Then physicists repeated the experiment with electrons, not beams, single electrons, one at a time. Electrons are particles. They strike detectors as individual dots, so the result should be simple. Two slits, two clusters. Instead, over time, the dots built up an interference pattern, as if each electron passed through both slits at the same time and interfered with itself. Stop. A single particle behaving like a distributed wave is already unstable. But here is where it breaks reality. When detectors are placed at the slits to determine which path the electron takes, the interference pattern disappears. Now it behaves like a particle. Nothing about the hardware changes. No hidden wires, no added forces. Only this: we ask a question, and the pattern obeys. Without measurement, there is no fact of the matter about which slit the particle passed through. The universe does not store the answer in secret. There is no hidden ledger, no invisible notebook recording the path. It is not hidden. It is not waiting to be uncovered. There is nothing there to reveal. Until the interaction happens, reality has not committed. No sealed envelope, no secret trajectory, only a structured range of possibilities. And the moment you measure is the moment the universe is forced to choose. Not unknown, undefined. And that distinction changes everything. To understand why this happens, we need a new model. In classical physics, objects always have definite properties. In quantum physics, systems are described by a wave function. In 1926, Erwin Schrödinger formalized its evolution. The wave function does not describe a physical ripple like water. It encodes probabilities. Before measurement, the electron exists in a superposition. Not here, not there, but a combination of both possible paths. Think of it as a probability cloud passing through both slits simultaneously. That cloud interferes with itself. The equations predict that pattern with absurd precision, and they keep being right. But the mathematics does not specify when or how one possibility becomes real. It only gives probabilities. This gap is known as the measurement problem. Maybe electrons are special. So, physicists tested larger systems: neutrons, atoms, molecules. In 1999, researchers demonstrated interference with large carbon molecules known as C60. 60 atoms bonded together, thousands of atomic mass units, still forming interference patterns. There was no clear boundary where quantum behavior stopped. The strangeness scales upward. If superposition applies broadly, why does your desk not exist in multiple places? Why does the macroscopic world appear stable? The leading explanation is decoherence. When a quantum system interacts with its environment, air molecules, photons, thermal radiation, it becomes entangled with countless surrounding particles. Physicists like Wojciech Zurek showed how this interaction suppresses observable interference. The delicate phase relationships required for superposition become scrambled. Interference disappears. Classical behavior emerges. But decoherence does not explain why a single definite outcome occurs. the wave function still mathematically contains multiple possibilities. We experience one. The selection mechanism remains unresolved. Then came an even deeper fracture. In 1978, John Archibald Wheeler proposed the delayed choice experiment. A photon enters the double-slit apparatus. After it has already passed the slits, we decide whether to measure which path it took. If we choose to measure the path, the interference pattern disappears. If we choose not to measure, interference appears. The decision is made after the photon passes the slits. The photon does not decide at the slit. It decides when the question becomes irreversible. The question reaches backward, not physically, but in the structure of the equations. Stop. Think about what this implies. The behavior is not fixed at the moment of passage. It is fixed when information becomes locked into reality. The past is not simply recorded, it is defined by the measurement context. There are only a few coherent interpretations. 1. The wave function is physically real. All possible outcomes exist simultaneously. Measurement branches reality. 2. Hidden variables determine outcomes beneath the surface. But experiments derived from inequalities formulated by John Stuart Bell strongly constrain local hidden variable theories. 3. Collapse is a real physical process triggered by unknown dynamics. Each option forces a revision of classical realism. None preserve the idea that properties exist independently in a definite state prior to measurement. This is not speculative philosophy. Quantum mechanics predicts experimental outcomes to extraordinary precision. Modern electronics. Lasers, semiconductors, all depend on the same mathematics that says particles do not possess definite trajectories before interaction. The double-slit experiment is not fringe physics, it is foundational. The experiment does not break physics. It breaks something more fundamental. It breaks the idea that the world is fully formed before you interact with it. At the smallest scale, reality is not waiting in a finished state. It is incomplete, and interaction forces completion. Before measurement, an electron does not have a single path. It has a structured distribution of possibilities. Measurement does not simply reveal a pre-existing answer. It constrains the system into one, not through consciousness, through irreversible interaction. Information is physical, and when information becomes irreversible, reality commits. We evolved to navigate solidity, clear positions, continuous trajectories, stable objects. But at the most fundamental level, the universe does not commit to a definite story until it must. 2 slits, 1 particle, no predetermined path. And a world that does not fully decide what it is, until interaction makes ambiguity impossible.